So we have three equations with three unknowns. You got to have some kind of systematic way of doing this so that you don't start going in circles. So I'm going to look at the first two equations. I'm going to number them 1 and 2, and I'm going to eliminate the y. So I'm going to multiply the first equation by 2 and have 4x plus 2y equals negative 8. And then negative 2y plus 4z equals 0. So when I add those together, I'm going to get 4x plus 4z equals negative 8. Well, this is pretty cool because then my third equation only has x and z in it. So now I have a system of two equations with two unknowns. So that's your goal, is to create a system of two equations with two unknowns so that you can solve. So I'm going to multiply this second equation by 2 because I can see that will eliminate the z. So I'm going to have 4x plus 4z equals negative 8. 6x minus 4z equals negative 22. So it looks like 10x equals negative 30 and x equals negative 3. So then I can come back to either of these equations to solve for the z. So 4 times negative 3 plus 4z equals negative 8. So negative 12 plus 4z equals negative 8. So 4z equals 4 and z equals 1. And then I can put this back in the second equation. And get 2y, negative 2y, plus 4 times z, which is 1, equals 0. So 2y equals 4 and y equals 2. So I'm saying my solution is negative 3, 2, 1. And remember that I can check my solution. That looks good. Negative 2y plus 4z equals 0. And 3x minus 2z equals negative 11. So I'm quite sure this is my solution. So I have a consistent system of independent equations because I found a solution, one and only one solution. Okay, so let's look at what happens if we have an inconsistent system. So I'm going to use equation 1 and equation 2 to eliminate the x. So I'm going to multiply equation 2 by 2, and I'm going to have 2x minus 3y minus z equals 0, minus 2x plus 4y plus 2z equals 10. Add these together, and I'm going to get y plus z equals 10. Now I'm going to combine 2 and 3 to try and eliminate the x. So now I'm going to multiply the second equation by 3 on both sides. So I'm going to get negative 3x plus 6y plus 3z equals 15. And 3x minus 4y minus z equals 1. So 2y plus 2z equals 16. So now I have a system of two equations with two unknowns. And I'm going to multiply this equation by negative 2 to eliminate the z. And I'm going to get 0 equals negative 4, which we know is not true. So there's no solution. So if you get a nonsense statement, there is no solution to the system, and it's called an inconsistent system. Okay, and then the last possible case is the dependent equations. So again, let's combine equations 1 and 2, and I can see I can just add them and the x's will cancel to get y minus 4z equals negative 3. Then I'm going to combine equations 2 and 3 and get negative 3x plus 6y minus 9z equals negative 12. And 3x minus 2y minus 7z equals 0. Again, making sure you eliminate the same variable in both so you don't get a big mess. So now I have 4y minus 16z equals negative 12. So I'm going to multiply the first equation by negative 4 to get the y's to cancel. Negative 4y plus 16z equals 12. Well, now when I add, I get 0 equals 0. So you need to remember that this is a consistent system with dependent equations. And it's a little trickier of how you write the solution set. So you let z equals t. Okay? So then you put t in the equation that just has y and z, and you solve for y. So you have 4y equals negative 12 plus 16t. Divide both sides by 4. So you're going to get y equals 4t minus 3. Okay, so now I have 4t minus 3 as the y coordinate, t as the z coordinate. Now I have to look up here and find a way to write x in terms of t. So I'm going to x minus y is 4t minus 3 minus z is t. So I have x minus 4t plus 3 minus t equals 1. So x is going to equal negative 2 plus 5t. So negative 2 plus 5t, that's going to be the x coordinate. So your solution set is going to be the set of all x, y, and z such that they look like this for all t is a real number. So t goes through all real numbers, but for each t, for instance, if you put t as 0, you can see that negative 2, negative 3, 0 would be one possible solution of this equation, system of equations, if for t equals 0. So suppose you let t equals 1. And then you're going to have 3, 1, 1. So you can come up with infinitely many solutions for this system of equations because it's consistent system of dependent equations.